All right, so we're looking in this problem for the mass of a meter stick. So the first thing we want to do is draw the meter stick. We know how long a meter stick is. It's a meter, or 100 centimeters long. And so I'm going to begin in drawing this with, here's my meter stick. It says, what would be the mass of the meter stick if we support the meter stick at the 58 centimeter mark? So if this is in fact, I should be writing, we support the uniform, let me put that word in. We support the uniform meter stick at the 58 centimeter mark and balance it by placing a 5 kilogram mass at the 92 centimeter mark. So what that means is if it's a uniform meter stick, if there's nothing on the meter stick, it would balance where? At 50. That's where it would balance. So what we're going to do is we're going to move the support, we're going to move the pivot point from 50 to 58. So the pivot point is going to be moved from right here, which would be the 50, right in the middle, to about 58. So I'm going to make that my pivot point. And it says, what would be the mass of a meter stick if we support the meter stick at the 58 centimeter mark and balance it by placing a 5 kilogram mass at the 92 centimeter mark? So if I put a 92 centimeter mark, it's going to be way over here somewhere. So I'm going to have 92 centimeters. So this is the 92 centimeter mark. That's the 58 centimeter mark. And we know that this mass is 5 kilograms. So I'm going to put, now I know where the center of mass is of the meter stick. It's at 50. So I know that the amount is going to be right there. And I actually know it's going to be much bigger, bless you, it's going to be much bigger than 5 kilograms. And I know that because if my pivot point is 58, there's a lot bigger distance between 58 and 92 than there is between 50 and 58. So I know that since this force is closer to the pivot point, then this force is going to have to be bigger in order to create the same torque in that direction as the torque that I'm getting from a 5 kilogram mass being located right there. So what I have on the board is pretty much the picture, although maybe I should also put in that I know if it's a uniform rod, then that's at 50. So now I've got all the numbers there. So now all I have to do is do my torque equation, and that's going to be the answer. So I know that it's balanced, meaning that if I sum up my torques, it adds up to 0. So if I sum up my torques, I'm going to get the 5 kilogram one. Is this making it go, well, let's do, yeah. Is this making it go clockwise or counterclockwise? Clockwise, because that's my pivot point. So a down arrow to the right of the pivot point makes it go clockwise. So I know it's going to be minus 5 kilograms times its distance to the pivot point. So what should I put in? 34 centimeters. All right, because the distance between 58 and 92 is 34. 92 minus 58 is 34. Now, this one, is that making it go clockwise or counterclockwise? It's a down arrow to the left of the pivot point. Counterclockwise, so I know it's going to be plus the unknown mass, so I guess I'll just use M for mass. Maybe I'll put it up here too. So we're looking for the mass of the meter stick, so I'll use the variable M, times its distance to the pivot point. And what do I put for that? 8. And I know that those two have to add up to 0. So now just rearrange to solve for the mass. So I can move this term, because it's a minus, to the other side and divide by 8. So M is going to equal 5 kilograms times 34 centimeters divided by 8 centimeters. If you move things around to solve for m, that's going to be your answer, and the centimeters will cancel out, and what will you get for the answer? What is it? 21.3. So 21.3 kilograms. So that's a pretty heavy meter stick. Probably should have done it in grams, but whatever the unit is here, you don't have to convert it. And I know it's not a force, it's a mass, but we can represent, mass. If everything on here is in mass units, then they are proportional. So although mass is not a vector quantity, and we really should use arrows to represent vectors, in this problem, I don't have to bother with converting this into newtons just to convert it back into kilograms, because I did ask, what's the mass of the meter stick? All right, any questions with that?